live. Okay, so we're gonna get back onto this. I came up with some ideas. There's still some stuff to decide though, isn't there? I think this norm is better. Really, it's just this transform that I need to keep. Yeah, I need to keep this transform. Okay. I think that what I decided while I was off on my run was that the way that we are going to do this. Welcome, Linky. How's it going? Yeah, I think what we're going to do is, first of all, this sweep.metric thing. Do I have this for wannabe compatibility? It's probably what I have this there for, right? But I don't use wannabe sweep, so that's irrelevant. Okay. So we will just go to method name metric goal. Fine. That is fine. Now we need to add some stuff. Maybe I should have left that in. Yeah, that was dumb. I should have left that in. Alright, no harm done. And the reason I need to leave it in is because I realized I need to add min and max to this thing, right? by default, but we're gonna do 0, and I guess 1 for now. At least leave it in the defaults. No, we're not deprecating WANB sweeps. We are dropping WANB sweep support, but we are still going to support sweeps in WANB, just not using their sweeps API. So you will have the same thing, just not with the WANB sweeps API. We don't do deprecated, man. Deprecated is like, oh, we'll leave it in for now to give you time to switch over. No, when something needs to change, we change it. Deprecated is for big companies maintaining legacy stuff. If we don't specifically have somebody we're supporting that needs it, then we just change it. Correct for carb. Carb sweep is gone. Carb sweep will be gone after this. I'm not going to ship this before I confirm that this is just massively better than carbs. This 500 line file is going to replace it. It's going to be less than that when we're done. Yeah, this one I think is worse. We'll start with this. Welcome, YouTube folks. This is going to be most of the weekend here on trying to make ridiculously good hyperparameter sweeps for reinforcement learning. Since we have a few folks on, I'll do a little bit of background while this experiment runs. My work here is based on InViewAI's carbs method. This is a work that's gone relatively under the radar, but made a huge impact on reinforcement learning. I really like it, at least. And it's a very mathy paper. It does a bunch of things with various different Gaussian processes. It's got like this soft trust region here. It does expected improvement over predictions from Gaussian processes, and it does a few other things as well. I've been going through the released code for this. I've used carbs itself for many months. Many people in Puffer have. And we found some things that could be improved, and when we started pulling at that thread, well, one thing led to another, and we are really rewriting the majority of this algorithm now, and fully rewriting the code. So we're now doing some work to see which ways we can improve this. In particular, carbs and most algorithms will horribly fail the majority of very simple benchmarks, which doesn't seem good. Your algorithm should not be failing simple benchmarks. So we are looking at the reasons for that, and we're going to get something that works very nicely on both simple benchmarks and then outperforms the original on all of our RL environments in Puffer. That is the goal. Norm. So the work process for this is pretty much just going to be me fiddling around with the algorithm, fiddling with the math, fiddling with data normalization in various ways, and then trying to figure out how to improve upon this. So this is interesting. Let me see what this curve is supposed to look like first. And then we'll figure out what's up with this. So the percentile task is a synthetic task. It's supposed to be simple. Welcome. Yeah, I see your chats. I just had forgotten to enable the chat earlier today. Like I made a different scene because I had meetings where I needed to screen share and I didn't want the chat on it, and then I forgot to switch the scene back is all. Howdy. Okay. So right here, this is the score, and then the cost is unchanged. So this goes up to 200. So let me think. 1. So score. Hold on. What? Over 1 plus x of I am confused. What did I make this for? Like, this is supposed to be a 0 to 1 reward, but I'm confused as to what I did here. So I think the maximum score negative log of the learning rate plus 3. Okay. Oh yeah, because x of 0 should be 1. Right, yeah, you do this, so it goes up to 1. And then, okay, so then what we do is, why not? The cost can go up to 200. That. So that goes up to about 1, yeah? And if we do like, oh, that's what it's divided by. I see. So this gives you 0.6. And we see 0.6. Perfect. So this is what it looks like. For whatever reason, it's scaled kind of weird. Oh, it goes from 0.5 and 1. Let's see. Yeah, but it's not being computed out far enough for some reason. So let's figure that out. Why are these given like this? There's also max cost to consider. But I would like to look at this. Okay, so... Oh, hold on, did I norm this wrong? I think I normed it wrong. No? Huh. Okay, well, we wanted to change this anyways, so we're going to comment these. YT. We're going to use Gaussian norm here instead of linear norm. And then I have to remember to undo this. There we go. Let's see if that changes anything before we go crazy looking at the map. The thing is that this should be pushing... This should pretty quickly push towards higher cost. So if it doesn't, then there's something weird. Oh, wait. I might have left this parameter in, right? Yes, I left this parameter in. Okay, that was done. 2010. So there's nothing wrong with this sweep. I just left a bad hyper in. Well, let's take a look at it at least. This should now much more quickly. Instead of capping it, it was being capped to cost 4. So now it's capped to cost 200. Still not push outward? That would be odd. Huh. That doesn't sit right. Oh, maybe. Okay, something's definitely screwy with this then. Okay, so it's pushing out, but very, very slowly at first. So why? Okay. See the quality. Okay, so this portion here looks reasonable. There are a couple misses. This is very dense over here. I'm starting to wonder why. Okay, hold on. So if you have your data distributed this way, it's roughly linear. Your loss function should be, or your score function should be pushing it out more aggressively than this. Let's go double check the log one just in case, because it's possible that I screwed that up. Log task times log 10. Log 10. Good. Oops. 2.3. We'll do 2.31. Max. 2.31. Can it go negative? I don't think so. So I want to basically make sure that I didn't break it in the process of doing what I was doing with the norms there. Because if this one also takes forever at the start now, then there you have it. Oops. I gotta remember to keep posting stuff on here. It's kind of silly that this is considered part of work now, but we're almost at 6,900. Nice. Okay, so this is this lower than before? I think that's like an acceptable pace, right? This cost is in units of 50 million. If we think of it that way, I think I'm pretty happy for it to take, maybe 20 experiments before it starts accelerating. But it only got up to 70 here. So it is slower than before. How did this happen? Do I have the other window? Yeah, so this is what we got before. Right? We got like something like this. Oops. And now we have a similar shape. This nice line curve, yeah. But it takes too many samples. It's just too many samples. Okay. I can check if it was the change of mean. Let me just see if it was this first before we do anything else. I think it's more likely the change of normalization. That should be able to make it more aggressive, not less. Well, we will see shortly. First community note I've seen on an AI model post. That's funny. Good note. Looks like it's going to be similar. So in that case, it must have been the norm, right? This is a little bit more aggressive. Quite actually somewhat substantially, right? Yeah, that's closer to the original. I think there's probably just going to have to be a coefficient that gets tuned. I think we're also going to benchmark this versus some random methods as well. So we'll tune based on that. Okay. So this is fine for now. This gets out to 150-ish. So here's just tuning up the, because I do think that we want to use mean scaling. So we're going to tune this up. So the full transformation, you get your score data, which is how well you did in the environment, right? And then you're going to first 0, 1 scale it. and then you're going to exponential scale that. So you get everything into a 0, 1 range, and then you apply this exponential transform, which basically, the closer you get to the max, if you cut the distance in half, you double your score. So you get this exponential scalar. And then we put it into approximate, we try to standard norm it, just because Gaussians like standard norms. I should do the same thing here. We're going to try this next. The reason I'm making these changes now is I did some testing this morning, and it seems like I was substantially underappreciating how much Gaussian processes rely on nicely standard normalized data. The 0, 1 scale is not bad, to be fair. We'll see. Let me think, actually. There might have been a reason I did that. Well, this didn't really do much. Let's try again with the new cost. Hang on. This might be something that I have to include both for until we test it out. Oh, you know what? Linear is correct here. I say is this just absolutely shreds it when I do it the other way. Let me see. What happened here? Why are these over here? It shouldn't have happened. This is bad. This is a lot of wasted compute. This curve is good, but these points are very, very bad here. Yeah, this jumped up too quickly, you see? This jumped way too quickly. Okay, we're going to try linear and norm. So we're going to do input norm linear. Just going to put it here for now. And then I have to do the same thing somewhere, don't I? Okay, now we rerun with this. Very good. Yeah, this is going to be correct, and here's the reason that I think this is correct. So this does slightly make it harder, or this does make it harder for the Gaussian process to learn the latent space, okay? Because it really likes normally distributed data. But that, like, the tails of that distribution are going to grow, and the tails are important, okay? And if you set, there's a mean function in a Gaussian process, right, which defines what the function does when you're not near any data points. So if you have a normally distributed data, then as that function grows, basically the Gaussian process is going to try to drag points down at the extremities very aggressively and in a way that you cannot control. Whereas if you have a 0 or 1 scale, then at the extremities it's always going to be the same drag force, essentially. So here we go with both linear. I think I left the aggressive scaling in here. We'll see in a second if this is too aggressive. It is covering the full space. Pretty good. Pretty good. Maybe too many points over here, you could argue. Let's try on the log task, or the, not the log task, percentile task. And we need to remember to scale this. This will be taken care of for you once I'm done. We're just testing some stuff. I want good coverage in all 3 tasks. This is fair. One of my other favorites here. Honestly, OpenAI 5 wins by such a huge margin Yeah. I think from that era, OpenAI 5 is the most important paper. Obviously, we're omitting like pure algorithm stuff, like, yeah, the PPO paper, obviously. But if you want to read one paper in RL, you read the OpenAI 5 paper. Model-free deep RL algorithms. Is this from Eugene's lab? We built. Huh? Eugene's at NYU. This is CMU? Ha! That's funny. So I've never heard of any of these algorithms, but apparently that doesn't matter because PPO wins, which is funny. It's very funny. PPO normally does win. I want to, so this is good. I have you I can kind of understand. I have questions for you, and I have big questions for you. Where's the 150 point? Oh, right here. So oh, but this was with the aggressive schedule. Yeah, that's too much. It's approximately double cost. Let me think about that. Double cost. That seems too aggressive, right? Okay, here's another way of thinking about this, right? So if you want to go from 100 million to 10 billion, which is like a reasonable experiment range, right? Whoops. Does this give you 4? Oh, other way around. Okay, so you need to double between 6 and 7 times to do that. So do you want to be able, your hyperparameter tuner, to be able to, in the course of 7 experiments, go from 100 million to 10 billion? No, that seems way too aggressive. What about 1.5? 11 and 12 experiments. A little better. 0.25 is going to be 20 experiments. Okay. And then an additional 10 experiments to scale outward from there. That's kind of what we would go for. We're gonna find a precise way to tune to this in a bit, but for now, let's just crank it down a little bit. The other thing we can check is how many experiments it actually took. I mean, this is kind of an outlier. Like, this all looks mostly fine. The thing is, I think this point's higher. Try this again, see if I like this one more. And then I guess we will... I mean, there's still some modifications to make. Where is their comparison? Holy, I did not know about this. I missed that. That's crazy. Solid paper. It's a very good paper. This is actually going to be this might be, I'm going to have to see how well done this is, but if this is done correctly, then this will be my candidate for probably most useful RL paper I've seen this year. Good job. 11-pager. Read this thing, guys. This is like the first thing I've seen that looks legitimately worth reading in a long time. The only thing is, how many games do they have? Yeah, they don't have, they need more M's, is what they need. All right. I would not trust OpenSpiel's implementation over CleanRL. Absolutely not. DM's not open. I follow you, but your DMs are not open. Fix. If you want me to message you for free compute and things. Keep your DMs on open on Twitter, folks. Okay, so we have, interesting. Let's see what this was. Okay, this curve looks very good, and then there are two bad points. It's kind of crazy that there can be 2 points that miss that heavily. Okay, and just to confirm, let's do let's try log. I was really hoping that they would have run that over way more environments, way more interesting environments than just hex and tic-tac-toe. Interesting how much that changes the dynamics. I think that makes sense, though. The mean functions get all messed up. I guess I could try to adjust the mean functions. Okay, let me see. Maybe this isn't terrible. So, this was before. No, it's not like this magically fixes it so that it never makes any errors, right? So I'm gonna prefer this one until I'm given compelling evidence to the contrary. These are very, very similar curves. So we don't need to worry about that one then for now. Good. We should double check this on the linear task real quick. Max 4200 here. Just to make sure we didn't somehow break this. I highly doubt it, but yeah. Highly doubt we'll have broken this, but we might have. Actually, let's just do that. It's good to me. Your line. A little aggressive, but not terrible. Mm-hmm. I almost want to make the total time steps parameter like its own thing, because it's the parameter that influences cost the most, obviously. And I don't know, you could probably do something with it, but this is mostly fine. Emery, what? I don't know who that is. Okay. Let me see if there's a little quirk that I wanted to address with this algorithm. Not going to matter as much for the synthetic tasks, I think, but yeah, okay, so right here, what happens if you improve an existing point? Okay, so you are nearest Pareto YT is going to be some score. You come up with a better score for the same point. The nearest Pareto distance will be 0. Okay? That's really bad. What if we took the point to the right? So you take the score of the nearest point to the left and then the distance of the nearest point to the right. Does that do it? I gotta figure out how to handle bounds with that, but yeah. Well, then what if there's a Pareto point right next to you? We can start with this. Nearest Pareto distance. Cost difference. So this sets it to 0 if there's nothing to the right, which means you can never go to the right, which is bad. I can clip it. I don't know if that's going to be enough. I guess I can explain this in the meantime. Okay. So, blueprint. Speaking of blueprint, I should take that. Does look like it is increasing in, the score is increasing. Ratings are infinite. Lovely. We'll have to fix that. Interesting to know how ratings are infinite, but it seems to still be working. That's a little bit disturbing. Ratings are no longer infinite. Got all the infinite alpha out of there. Oh yeah. Okay. I'm actually curious to see what this looks like, because this might actually be a decent run. Be funny. That's actually one of the cleanest runs, ironically. It's a very nice spread. Let me figure out why these are infinite real quick. And then we'll go through the algorithm, or the changes, at least. Okay. Can you check if is inf? Oh, so that's actually funny. So what that probably did is it just kept pushing it aggressively to the right, and because the model happened to be good enough, that's why you got the very nice spread. Heavily rewarded for going off to the right. So we'll keep that in mind. So here's the deal at the moment. You have an underlying curve you're trying to discover that probably looks something like this, right? You got a Pareto point over here, you got a Pareto point over here, you got a bunch of points you don't care about here. You have a predictive model that will try to get you a good set of hyperparameters somewhere here. So where should you sample? What this is at the moment is that you should take, if you're going to try to assess how good this point is, then what you care about is you care about this height and this distance. Both of these are nicely normalized because this curve could come to you with any scale this way and any scale this way. So we've normalized everything to be pretty clean. Let me just ban that bot. And it says you should multiply these things. So you take this distance, so this is distance, so this is A, this is B, then you do A times B. So this is the graph that matters here. Let's see what this just did for us. I think this will be a good, but not quite as good as the previous one. So, oh, actually, that's very nice. That's very stable. It only goes out to 50 is the problem. Very nice graph, only goes to 50. So the thing that we have to think about here is what happens if you sample, why is this an object? Hello? Hello? All right. What happens if you sample a point here? And what happens if you sample a point here? These are the two difficulties that need to be addressed. Because then you need to somehow do this distance, and you need to somehow do this distance. Right, so both of these are problems. trying to think what would be the most principled way to choose this. Because really all we're stuck with are edge conditions, and actually I think that this probably explains why our Pong algorithm was bad before as well. It kept trying to go for these really cheap runs because it was looking at this distance and saying, look, look how much benefit I get by taking this distance. Do you use the mean, the median? I mean, we could try some stuff. We can do mean, cost. Mean, cost diff. Then we can do breakpoint in here somewhere. Should be able to do this. I'm just getting tired. Let me see. Less than 0 is infinite. Oh. Something like this, probably. Let's see how this works and then decide to clean it up or not. Just take the spread of points. Just assign it the mean. I think mean's better than median. It's robust to clustering. Median could be better, I don't know. I think the mean is just fine. Oh, median doesn't even make, yeah, median's more annoying to compute in this case. Algorithm does not agree. Algorithm says not happy, apparently. We will be interested to see why. Silly. Okay. That looks really good. It's just pretty passive, is all. I mean, can't we control that with... I don't know if we can control that with scale, can we? Let me see. If I just set this to like 3 or something, does this like change it? I don't know if it does because this is now in the scoring function that we've changed things. I mean, mean Pareto point distance seems fine to me. We'll see if this this does anything. This is very clean. Oh, okay. That's pretty solid. 100. But the scale, I think, has a limited effect. Hold on, maybe this is a good thing, though. Maybe this is a good thing. Yeah, wait, I was... Okay, I see. I think I know what happened. Give me a second, and then I will Let me just confirm that I'm right here. Yeah, okay. So you were kind of getting, there was kind of like double incentive to really spread the graph out before. And the reason here, actually, we will go back to the diagram. So the reason here is you get rewarded for this distance, right? And you also get rewarded for this distance. So the way the algorithm works, right, is you sample a whole bunch of points around the existing points, and you get rewarded for having the prediction be better than the nearest point to the left, and then you get rewarded for being farther than the nearest point to the right or whatever. So in the original algorithm, before I made these changes, you're incentivized to put the point as far to the right as possible, both by the fact that that's probably going to get you higher score, but also by directly this distance farther to the right. So now, instead of just putting the point as far to the right as possible, let me think. You're still incentivized by the cost to put the point as far to the right as possible, right? But we've just made it less aggressive because you get the mean distance between points instead of just getting the however far you're able to put it out. Okay. So actually, this is good because this means that you're driving the frontier exploration via cost improvement, not via via score improvement, not via cost improvement. Now the only difficulty here is it's still very passive. I mean, this is with a crazy coefficient set. It's still not spread out the way we'd want. Not quite. You can't just crank up that coefficient either. You can't just crank that coefficient indefinitely. I can stick it at 2, I think. The highest you'd want. But then the rest of it, an example that we like this, good. Honestly, this one is really nice. Just so passive. Why is this so passive? 3xing it goes out to 100. You don't want to 3x though, it's just, okay, this isn't bad. 2x. Let's think about the knobs that we control here. Because it should just be a matter of tuning this thing a bit now, right? We have length scale set. That's a really big length scale for a return, isn't it? This is going to make it even more passive though, isn't it? Let me see. Maybe not. This length scale might need to be set to actually 0.1, come to think of it. Yeah, the scale length is crazy right now. I think that makes it trust the return kernel like hugely across the whole space. Not great. Seems to make it worse though. Yeah, so it's less aggressive. The return has to fall off and the linear has to take over. So this didn't help. What other knobs can we fiddle with? I mean, the ironic thing here is that probably if I just do this, me see if I understand. If I understand this correctly, then this should be very effective. If I understand correctly. Interesting. So hang on, this worked. This was what we had from 2x scale, right? I think this is in the middle. Okay. So this one ended up pretty far out. It's a crazy jump. So actually, wait, this is not a crazy jump because it's allowed to like double almost, right? Or 1.4x, yeah. So it's allowed to go up to like about that much actually. It could go up to like 20, yeah, 28. This is about what it's allowed to do. So it's about the max jump distance. This is perfectly clean. So I'm happy with this. Let me try something. Because I think I understand this now, but I think that in order to really sell it, we need to do so this is what happens at the extreme when you are really heavily rewarded for scaling to points off to the right. It should just go up constantly. Oh, hey, yeah. Oh, this is a different Yash arm, it looks like. Huh. I know a different one. Yeah, that's not good news. Good luck, but that's not good news right there. Poor folks. Oh, man. Raising 1.2 mil VC is brutal. Oh, was I? No, this is rivals, right? Yeah, that's just silly. Okay, so right here, this is, yeah, this is the really aggressive expansion setting. All right, so this is actually, this will be very good data then. So this is with 2x, and then this. It's the exact same thing, just rewarding you way more for going off to the right. It's funny that you don't get the distribution you'd expect. I mean, it does push to 200. It only makes one major error. I would think that's pretty good overall. You could take the max instead of the mean. Let me think about that. Hey, how's it going? We are working on this hyperparam sweep algorithm. It's tricky. It's going to be really good when it's done, though. Very, very good indeed. Mhm. It's funny how much pressure this thing needs. I mean, I guess it makes sense. Actually, there's one thing I want to look at. It's occurred to me that the reason that we need to add such aggressive parameters so that it keeps finding more expensive points is we have two different Gaussian processes. One of them is pulling this way and the other is pulling this way. We're pulling it straight back down. Point 1 unit away contributes half as much. Well, I have a lot left to learn. Oh, please don't mistake this for me knowing what is going on here. This is not the type of stuff that I normally do either. I just figure that regardless of the lack of heavy probability and stats background, I've at least seen these things before, and I know enough about how reinforcement learning is supposed to work to be in a here. This is how I generally look at stuff, right? I might not always know what I'm doing, but I'm the most qualified to figure it out. That's a fine place to be. I'm not the most qualified to be specifically looking at this math, but overall, for getting this thing working in RL practically, yeah. Hmm. Does that even have fall off? I don't think it does. I don't think the linear kernel has fall off. No localized decay, yep. Do we need the linear kernel? What happens without the linear kernel? What happens without the linear kernel? I mean, we're making progress. It's a lot of 2 steps forward, 1 step back, but the main thing from today has been that all the data is very nicely normalized now. So in the actual space that you're learning, this axis goes from 0 to 1, this axis goes from 0 to 1. There are a few other improvements around that. It's a little harder than it would normally be just to scale your data, duh. Yeah, looks like you need the linear kernel. You really shouldn't. Let's see if we actually, maybe we get something similar to the original plot, which one was it? And then went to 12. Only up to 8. It's very clean. But you can see the predictions getting pulled down. Put the linear kernel back. I'm trying to think what the most principled way of doing this is. I could make it a meta hyperparameter. We're trying to avoid those if we can, but I see we have new YouTube people, so here, I'll go through the thing again. Maybe I'll figure it out in the process of going through it. Oops. So the way this algorithm works, right? This is the curve that you're trying to fit. This axis is cost, which is how long it takes the experiment to run. This axis is score. This is how well your experiment does. This is the Pareto front. This is the set of like best experiments in a sense where you can't make the experiment any faster and also better. So let's say that you have 2 existing experiments like this. These are optimal experiments. Maybe you have some others over here that we don't care about. The way the algorithm works is you generate a bunch of candidate points to score in here, and then you score them as follows. For a candidate here, you're going to score it by multiplying this distance, A, by this distance, B. And the idea there is that you're incentivized to improve the score over the nearest optimal point, and then you're incentivized to spread them out so that you don't put a point near an existing optimal point. The problem is when you have to score a point here or here, right? Then you have this distance and you have this distance. So figuring out what to use there is difficult. And that's what we're trying to figure out. So I have some ideas for the one on the right that I've been trying. What about the one on the left? Maybe I should think about that one. Maybe that'll give me some clues. So for this one, we want the cost difference. The difference in cost. Nice PDB logo. What? Where do I have a PDB logo? Well, maybe this gives me some clues, because you definitely can't use the max cost difference, right? The puffer. It is just the shell prompt, yeah. We just use, when you have, it tells you that you're in the container. So if you download Puffer Tank comes with a puffer as the prompt. You can obviously change it, but that's what we use. Puffer Tank comes fully loaded with my editor setup and with the puffer. Okay, this is kind of informative, because if you just keep assuming that you're going to use like the maximum difference or some large value, you're going to keep trying to put points here. You're going to keep trying to put points over here, even if they are very close. However, cost is normalized between 0 and 1, isn't it? Cost will go to 0 at the minimum. So I can just have that one be 0. I think I solved that one on the left. I should just be able to have that one be 0. Score is normalized, cost is normalized, so the one on the left should be able to just go to 0. That's not bad. But hold on, I don't think I do this score in normalized space. GPYT, Pareto YT. YT is, so I would have to do this in YT norm space. And then the distance, I think the distance is done in standard cost space. If I were to do both of these in norm space, which would require me to rescale some things, but I think I probably should, that would have some nice interpretations. The maximum possible score would be 1, because the maximum difference on this axis will be 1, and the maximum difference on this axis will be 1. That would be good. And then I could use just use 1 as the distance. That probably works. I want to try that. That sounds very good. I think yeah, I think this is the way. Okay. So, first thing we will need to do, PYT. Nearest Pareto. Okay. Nearest Pareto. This one's a little annoying, but I should just be able to do C right, Pareto, log C norm. GP log C norm. And then we do equal to one minus GP C norm. Let's make sure this works. You could also just set it to 1. If this works, this will be very nice. That should not be, should it be a different shape? I guess it's fine, yeah. Oh, it's a tensor. Actually, let's just do 1 for now. I think that'll be the simplest. Actually, hold on. No, it does need to be 1 minus. Otherwise, it doesn't make sense. We have to finish the full implementation, and we'll be able to see if it's good. This is gross, but this should run. Suggestion scores. Hey, welcome. Seriously, how's this still a problem? 372. C, right. Free to log C. C. Where's the other one? Right here. We'll see if this works. And if so, I will go through it. Okay, cool. So what I did here is I moved the scoring function. So what happens here is, right, internally, this data comes into us in whatever format it comes in. And then we turn it into 0 to 1. So this will be 1, 1, and 0, both of these axes. But I was still doing the scoring function in the original space. So now, if I do the scoring function in the latent space, first of all, it's a 0 to 1 function, or I guess negative 1 to 1 if you mess up. So it's nicely bounded. And on top of that, I think the bound problem gets fixed for us, because see, if this is at 0, the issue that we were having is we didn't know how to score this point, because usually it's based on the point to the left, right? Normally you would, if you're looking at this point, you would go to the one to the left and look at this distance here. So there's no point to the left to look at, but since it's normed to 0, and you can actually go all the way to 0, we just get to use this distance here, which actually I think I forgot to do in this update, so I will fix that. And then the one here, this one is going to be slightly more complex, but if you put a point here and this is at x, then it's just 1 minus x, right? So it's just this distance cut off at 1, because we know the axis goes to 1. That's quite good. Now, where is the mean? We have to rescale everything, though, to do this, which is a little annoying. So we have a little bit of work to do here. Oops. So 0, 0, 0. Okay. Run it again just to make sure it doesn't fix. And then from there we can actually figure some stuff out. is very good. I can tell we're getting very close to having this thing done. It's going to be, I mean, this is a sizable project, this investment. I think this will pay off. All right, what's this look like? Obviously, it's not a full curve. Interesting. Uh, huh. The predictions are not bad. Yeah, no, the predictions are quite accurate, right? Yeah, these are the early ones. You can ignore the blue ones. These predictions are quite accurate. Oh, the red dots are clustered up. You can kind of see it, right? Let me make sure that's correct. They looked like they were clustered up. Hold on. Clustered. Yeah, 1, 2, 3, 4. See this? So this should not be allowed to happen. This should give you very, very low score. So that means we have a bug. Suppose it's better than the thing being implemented correctly and not working. You have your differences. Nearest Pareto distance. Oh, hold on. Let me see something. It put this one, then this one, then this one, then this one. And earlier on it did this one and this one. That shouldn't happen. There is a check on that. It is very difficult to take care of scaling, though. Yeah, because you can't. The problem is that no matter how you scale it, there's always going to be weird stuff in latent space. So the only thing I can really do cost is in log space as well, right? You kind of want it in linearized log space. Let's do that. So we'll leave the C alone. I think that we got the cost. I think what we screwed up for score. We want Pareto C. Okay, so we do this. And then we do Pareto C. Do I have norm? Did I already do that? I don't think so. And then this is GPC. Don't we have GP? log C norm, GP log C norm. GPC. Okay, so now this is 0, 1, right? Now we do Pareto C norm minus GPC norm. And then I think we do abs. Abs. And then this will always work. So we can just do nearest Pareto distance. NumPy.min C right. We will see if this works. Let me use the restroom real quick. Be right back. Well, that's a result. Well, it magically works. It makes a couple mistakes, though. Magically works, but makes a couple mistakes. Which are... Is that easily fixable? I think that's easily fixable. Yeah, that is easily fixable. Okay. We figured out how to do that. Where do we put the clipping on? Suggestions. It's a clip. GP cost. Ooh. kind of awkward. Hang on. We do clip the suggestions, but then it overestimates. Why would it do such a thing? Got nothing better to do? Look. What you doing? Trying to fix a hyperparameter sweep algorithm. This would be a major contribution across the whole stuff, the whole set of RL things that we're doing. If I can get this thing to work, I mean, it depends how much better it works than the originals. But if I get this thing working substantially better than carbs, this will be a major, major win for the field. So that's cool. If you type too many things or you put links or stuff, sometimes YouTube will eat them. I don't have it set up to do that, it just does it. So the only thing I have questions on, why are there so many points right at the end here, right? Can't do anything over here, over here. It's probably the exponential score weighting, right? Would have to be. 0.04. Yeah, it's got to be that. The score differences get accentuated dramatically. That's actually kind of a tough one to fix. Let me try something real quick just to test. Briani. Okay, this is something. Oh, wait, the initial curve on this is... The initial curve on this is really good. Some of the predictions are a bit off. Let me see. If nothing else, this will show us that we, I think the last piece to look at is really looking at the score norm. Still doing it. Arizona's a perfectly fine state. Had some friends from there. That's pretty good. Now it's like way oversampled right here, right? Yeah, so it's way oversampled this thing. 3, 4, 5. But that's not terrible. That's not terrible. It's quite clean. Less than a quarter of the compute spent. Should be like half, shouldn't it? And that was pretty darn aggressive how it did that. Let me go look at the auto param. No, it's not. Let me look at some of these jumps. 26 to 34, 51 to 64. Yeah, these jumps are all within the allowed range. Interesting. I almost want to make it jump slower here. Now that we have this. And then we'll have to play with that scaling factor. Try this. Just to see. This might be too passive. Could work. Good Twitter day for RL, I guess. 6908. Very nice. uh, yeah, so this is too slow. It's kind of funny that literally that's all I change is this one scale factor, right? That's all I change is the one scale factor, and it's really, really cripples it. Okay. So, this is our chart. What do we do about the score? I mean, any way you look at this, this is too aggressive. You should not spend so much of your compute on these long experiments. I mean, it's fine here, I suppose, but And this is why we'll need the real benchmarks. I think what's going to happen in a real end where it's harder to model the performance is that this is going to push it to expensive experiments too quickly. So why does it do this? It thinks that it's going to be getting like 10% higher. So this is max score prediction. And this is like 0.1 because it's a 10% increase. So yeah, 0.1, 0.0, yeah, that tracks. So that's screwy. Does it find anything better than this after? Doesn't really find very many things better than this as well. This one is 0.13. Yeah, okay. Do we have to cap this cost prediction? Get rid of that. How do we cap the cost prediction though? You can't cap it, it's a prediction. Okay, that's an issue. That is an issue. Hold on, shouldn't this be 0? Does this work? Let me see. Yeah, and we can't even cut it off. That's obnoxious. Okay. Because it's 0 to 1 normed. How's it over predicting cost in the first place? Bad modeling. You're taking the most wrong of a lot of the predictions doing this. Yeah, that is a problem. Well, is it? Yeah, because you should go back and run. Shouldn't go back and run more experiments. You should be filling me in as you go. Hard to say. The problem I'm dealing with at the moment is you don't know the maximum cost. And you're measured by distance to the nearest cost. So if you just have a wrong cost prediction, you're going to overshoot. That's tricky. Who works on Valentine's Day? People trying to get shit done. Who watches random dev streams on Valentine's Day just to make stupid comments? Yeah, but you're not making stupid comments is the thing, Plasma. This is a tough one. This is just a boundary problem, but I'm not quite sure how to deal with it because there's really no way to know the maximum cost based on your parameters. There's no way to know that. And if the model just predicts over the max cost, I mean, technically it should get better over time. Like you can see 230, 216, 210, 209. Like it will eventually correct itself because the model will get better. Maybe it's fine there. What if I run this thing for longer? What happens if you do like 100? Prepping for interviews? Yeah, that's a rough time. It should get better over time because, well, there are more data points to fit. It will fit, if it's going to fill in the boundary, then that should fix the model at the boundary, and then it should explore other regions. And then the only thing I need to look at then is the score normalization function. So we'll run this, we'll see if I am correct on that, and then we'll look at the score normalization function. I think that's the only really questionable choice left, right? Yeah, that should be the only really questionable choice left. Was there a reason I decided to predict log cost as well instead of just cost? Let me think about that. I mean, that could be varied. Yeah, there are lots of small things to tweak still. I think the main one that the main one we really need to look at though should be the score transform. Okay, so by now, yeah, so here you can see, right, we did the 200s, it went over 200, but now we're getting all sorts of other points. So it's gone back. And it's got an accurate model. Okay, this is perfect. This is exactly what we want. So that problem is that's a very temporary problem, the thing that we ran into. It'll probably drop a few points at max cost if it gets there, but then it'll go back. So this is behaving the way that we want it to. This is generally good. This is probably enough to even start doing some real experiments, though we might want to try it on a few more of the synthetic tasks first. The only one it shouldn't do too well on is I think the percentile task, because we messed with the epsilon. Okay. So here, oh, that's beautiful. Holy. Yeah, that's beautiful. Look at that. So the red points come later, right? So it filled this in and then it went back substantially into the curve. We don't really care about the really early portions of the curve, but look at this. It filled back in. Isn't that nice? Yeah, colors iteration index. This is the one thing that Neptune doesn't have that I really wish they had. It kind of gives you a third axis. Right, this gives you a time axis. That's like perfect. And so we should be very happy with this. Do I try this on the percentile task? Okay, I'm not going to have super high hopes for the percentile task because of the normalization we're using currently. But we will check it. Is it 5? Error while computing log prob. Really? Y over max score. I think that might be numerical. But you have the epsilon term. Let me see. You have y. Divide by max score. Really? That doesn't make sense to me. I accounted for that, so something's weird. Why is there so much random garbage on the darn timeline? Yes, use China's version of X. X, but CCP. Lovely. Let's not. No. We will not ever do that, thank you. I have not once used TikTok, and I'm not going to start. Chamber of lobotomy. I swear short form content causes ADHD. It's fucking awful for you. It's like, I know what'll make me feel better. 3 hours of scrolling short form content, said no one ever. How is this thing having error computing log prob? What? Nance. Jesus. I've definitely done longer gaming sessions than that, but not while scrolling garbage. I tried to limit that lately, though. Got a company to build. Got a field to solve. Well, I've definitely done 24 plus. There's been some absolutely degen gaming. I don't even remember. That was from when I was way younger. I've definitely put like ridiculously long sessions into a couple different MMOs though. To be fair, I got a PhD thesis out of MMOs. Nah, mostly old school RuneScape. A couple others that are less commonly known. Yeah, I mean, the main thing that my work was known for is originally, this is the latest version of it. This is an ultra high performance an ultra high performance MMO written for reinforcement learning research. Oops. Wrong button. This thing runs at like, I don't know, 10,000 times real time. One of the most complex RL environments out there. And a lot of the design and stuff is taken directly from my knowledge of the internals of how MMOs are built, just from playing them for so long. See ya. Jeez. Okay, so YT does have a nan here. That's not supposed to be possible. How did that happen? Let's see. Or and cost. Somehow it's getting a score greater than 1. Okay, that's weird. So it doesn't actually get to there. But somehow we have a score. Is not a 1.22. That's not possible at all. Output. Let's see. Self-suggestion, output score, cost is cost. Okay. If cost. Wait. Score greater than 1 breakpoint, right? How does this thing get into this? Are these backwards or something absolutely insane? Score. Cost. Score is score. Cost is cost. Oh, I'm stupid. My bad. Just getting tired. It'll be good. Hey, boss, I got this new... What? Damn it, Ryan. Get out of here. Well, I'm not gonna give you neocarbs access early. Nutcase. Do you know how many fucking DMs I have? Look, let me just show you how stupid this is. This is... Almost all of this is meme coin. It's all meme coin and sex bots. It's god awful. And it's like, I occasionally get client inquiries through there. So it's like, that really shouldn't be spammed. Can I? You know what they should do? I would like legal protections against cyber attack to be stripped from spammers. So I think that legally, if somebody spams you, you should be able to DDoS them or like, I don't know, try to like just screw with them somehow. That's what you should be able to do. I should be able to like, to set their keyboard to Dvorak or something and delete the settings files from their OS for other like layouts. I should just be able to do dumb shit. What are you working on today? Neocarbs, or, well, name in progress. This is getting to be very good, at least on the synthetic tasks. We have to run a lot of experiments on it, but I think this is going to be really good. It's based on two quantities at the moment, which is your expected performance improvement over the nearest Pareto point, and then it's also based on a distance and cost space, so distance from nearest Pareto point. Neocarbs, hyperparam sweep. We're gonna try to improve carbs by a lot. I've been working on this a while. Yeah, is that. It doesn't yet, to be fair. I don't know if I want to call it neocarbs or not. We barely use anything from carbs, so like, you know. Find a way to call it protein. That'd be funny. I don't know if I want to have some puffer adjacent thing with it. We'll see. But it's quite good. 017. I don't understand how this is. O22. Hypers. Okay, that's more reasonable. So this says 88. So that looks correct, but then what the heck does this do? .22. Huh? Oh, you're dumb. That's why. Reason is you're dumb. Love it when that's the reason. Spam running baselines for syllabus. Got tuned hypers for a few methods, bunch of environments, and starting point for people. Yep, that is very good. Puffers at the blackboard. They're schooling. Oh yeah, speaking of schooling, I was thinking of building a high-performance pufferfish swimming simulator and then trying to use reinforcement learning to see if we could get them to school. Does that sound like a fun and completely novel project that you'd want to be involved in? We'll make sure to simulate fin tip vortices. Yeah, we should definitely do that in C++. That sounds great. We should just choose the worst language out there. Other than Java, maybe. I might actually prefer to write Java than C++. Like, geez. It's a tough call between those two. I think submitting PRs in either of those gets you bitch slapped back to programming boot camp. The Zig people are kind of okay. Like, okay, yeah, you got a new trendy language, that's fine. I just don't want to deal with it. People made like, it's, from what I've seen, it looks like a lot closer to what C++ should have actually been. Rust, no. Julia, not really. Mojo, absolutely not. C is really nice, though. You should come write some C. It's just good. I don't want to write any more environments. I haven't tried writing them in C yet. It's actually really chill. You just do fast game dev. You just do fast game dev. I would like to know why this is so bunched up here. Oh, it doesn't suck. It's pretty nice. Have you seen the new Neural MMO 3 code? I mean, this thing is like way better render quality, 1,000 times faster, fancier UI and everything. And all the code is right here. That's the whole code. It's a fraction of the length of Neural MMO 2. And this is all brain dead as well. There's nothing in here that a first-year CS undergrad won't understand after taking their first systems course. There are no double pointers. I think there's like one dynamic allocation for the maps being too big, but other than that, no dynamic memory allocations. By which I mean after you call init. No dynamic allocations. No macros. Just conditionals and loops. Ifs and loops. That's all you do. Honestly, the hardest part of this whole thing was figuring out how to get the bloody the tiles to look nice, like the tiling code not to look like Minecraft. Interpolating and like snapping tiles and stuff for the renderer was the most annoying thing. Baseline roots. Yeah, Neural MMO 2 is a much more complicated and difficult to work with project. You should just run some baselines on this thing. I mean, this thing is solid. We have policies that train for this at 500k steps per second as well, like million parameter policies. There you go. Look at that. Oh, dodges. Dodges, picks up the tool, picks up the bow, doesn't realize that level 7 is too high to fight back on low HP. But that's pretty decent. You just saw that, right? It just executed multiple dodges, picked up a tool, picked up a weapon, swapped to the weapon, didn't realize though that it was too weak to beat the level 7. Dodge, dodge, doesn't realize that this guy has ranged. Doesn't realize that the really high levels have range. Okay, gets the level 1, picks up tool, equips tool, collects a bunch of stuff, kills. Does it know to equip the armor? Yep, it's got the weapon and it's equipped. It doesn't equip the boots. It's got the helmet on, it's got the chest plate on, it's got this. What happens if you train way longer? This has played 1,500 years worth of games, though I really didn't tune the hyperparameters of the architecture or the rewards much. So I think we can do lots better. But it only takes it. This is like 3 days of training on one GPU. It does some pretty sophisticated stuff. It's not perfect. Like, you can see there are clear gaps, but like there very well could be just stuff you can't learn from the current observations in there, right? Like, you need to renorm the observations. So yeah, I love this project. And eventually, you know, there will probably be successors to this as well, or expansions or whatnot. Like, this will continue eventually. I gotta build a successful company first. Yeah, but come on, this is pretty cool, right? Like, I built like a mini MMO over a few months, and now it's like the most complex, probably the most complex fast environment out there. I don't think that there's anything that is both faster and more complex than this. Honestly, the rendering was the only shitty part. The logic is pretty nice. Yeah, right? C is really cozy. Well, you can try this out then, because it's pretty fun. There's tech in this as well. Let's take over. Okay, I'm gonna reset real quick. Okay, now I'm gonna play this. So now this is me playing it. Let me see if I can show you that there's some tech in here. Don't you hit me. Okay. Let me see if I'm good enough to do the tech. There are a few different ones, actually. Oh, this guy's perfect. Yeah, you can strafe if you're good. I get the level 7, let's see. Yeah. So there's tech. There's technically, I think that there's a tech with the sword as well, because it hits in like 3 squares in front of you. So I think there's a corner tech. I think there's like an enemy pathing tech. Like, there are lots of things that you can do in here that are pretty cool. That would be it would be awesome if the bots learned to do. Yeah. I miss hitting lots of buttons. Man, I've been playing Overwatch. I don't know what's wrong with me. And then I did that, and then they're launching the biggest update to that game they've ever done next week. My hitting lots of buttons game is RuneScape, so I'm not allowed to do that. Because that's actually heroin. That update looks awful. Are you kidding me, dude? It looks awesome. Loadouts for everything? Looks great. Balance is going to be so bad. I don't understand balance. I understand swing hammer. Okay? I understand swing hammer good. I've hit silver all rolls. Ash one shot. Can't one shot him if you're pinned. Alright. And also it's silver, they can't hit anything. It's weird how it's like there are points over here. There's no points over here. There are no red points in this region. I was there for a week. Yeah, you and your cracked out aim. Okay, sometimes I miss the freaking hammer swings, and then I have to go play Winton. Wish I knew why this was doing this. I guess I can tune the exponential. Do 5 here. Hammer. Yeah, Ryan is good. It's annoying as hell on tank though, because you can't just play one thing every game. Like other roles, there are like you can just play the same thing every game and be fine. It's annoying. Yeah. Oh, it's gonna cause tons of issues, but it's still gonna be fun. I think the two I haven't figured out are frickin'. Well, I have mostly figured out, but it's like I've only figured it out because they're bad. I think if somebody actually knows what they're doing on Ramatra or Malga, I don't know what to do. Ha ha! Oh! So ridiculous. Alright, this is doing work. Rem versus Ryan. It's not that bad yet because they're not aggressive enough, and they don't understand that they're dead once they're out of Nemesis. But if as soon as they figure that out, what the heck is wrong with these cost estimates? Why is the model just like suddenly insane? That's crazy. I guess it's this epsilon term. It's permastock. That's... Uh-oh. Yeah, that's weird. It shouldn't even be able to do that. Twenty minus 2 is 0.99. I think that doesn't... I might leave it at 1e minus 2 for now. Perhaps it's 530. we're going to start to clean this up, and then we're going to be able to run some experiments on this. This has been pretty good. I wonder... I kind of want to check on the log. I don't want it to obsess over the high range of the cost is the only thing. See ya. Good luck. And the only thing here is I don't want it to obsess over the high end of cost. Here it definitely obsesses over it. I mean, I can do this, but I think this is going to start to screw up the results, right? So this is a little, let me explain what's going on here. I did this thing where I exponentially scale the score. So as you cut the distance to this to max score in half, you double your reward in the latent space, basically. This gets unstable towards the high end, but also you kind of need to have those like really big jumps at the top, because let's say that your thing is win rate, right? You want to go from 0.99 to 0.999 win rate. Like that actually matters. Or like if you're doing, even if you're doing something like Pong where the max score is 21, right? You want a consistent 21 max score. You don't want 20.5. So probably this breaks things, but we'll see. Lots of notifications. The heck? So much spam on timeline. Okay, this is a way better distribution over costs initially. And this is getting very good scores. So it's still getting high rating for this. There's probably some math detail I'm missing, but this actually looks very good. Let me look. So this is before with the lower epsilon. Huh. Why is it so obsessed over here? Maybe it's not better. Spends more compute here, but that's about it. All right, well. E3 gives you... I'm going to set this to 23. I'm going to run it again just for good measure. And then we're going to stop tuning this and we're going to mess with other stuff. And then what we'll do is we'll set up some runs on some real environments, I think. Yeah. And in the meantime, I'm going to start looking at how to clean this up a little bit, which I think will be important. So can I get rid of this normal option here? I think we figured out that this makes stuff a mess. So we're just going to leave this as the main one. Yeah, I hate options and things that like make the code longer and stupider. I think there's still technically a couple weird edge cases here. Not terrible though. Okay, we've got params, eps, y max. Do we care about y max? No. We don't use any of this crap. Min score. IT min. Norm. From. It's fine. Okay. Let's see. New train. Get the suggestions. Got NumPy. Renorm. Let's do this one. This one. Pareto. YT, C, and log C norm. Okay, so you have your Paretos here. So Y and cost. Yes. You don't use this. You don't use this. So Y. We do nearest Pareto. Pareto Y. C, Pareto log C norm. Okay, and then where's Pareto? Oh, this doesn't get used. Okay, so we use Pareto C. And Pareto norm? Yes. UPC norm. That's a little better. Just a little bit. I don't know why they're clustered like this, but whatever. It's probably pretty hard for it to learn to predict the fine-grained differences here. You'd think that it would get it on cost, but not a huge deal. So let's finish cleaning this up, and then I think we can throw this on Pong pretty soon here. There's just a mess of things here, so like nearest Pareto Y. Do we use this? No. I don't use this, do I? Because, yeah, that's gone now. Okay, cool. So, it's pretty good. I'd say that's solid. Make sure I didn't break anything in the process of doing that. I think I'd actually rather run the log one. For folks on YouTube, this is hopefully towards the end of having a working, very nice hyperparameter sweep algorithm for reinforcement learning. While this runs, so the algorithm that we've landed on, it's a little different from the last time I went over it. So, idea here is this is your curve. You have on this side cost, and then this axis is score. And your goal is to discover this curve, which contains the set of experiments that you can run where there's nothing up and to the right. So there's nothing that's cheaper to run, that takes less time, but is also performing better. So the idea here, I'm going to move that point just to make it more obvious. The idea behind the algorithm is that you're generating a whole bunch of potential points that you might want to run. Each point is a set of hyperparameters, and then when you run the experiment, it's going to end up somewhere on this curve. And we're training predictive models as well as to where these are going to end up on the curve. but you still need to know which point to select. So what we say is that there's a point here that you want to select. What you do is you're going to look at this distance, so the distance vertically from this point to the nearest point to the left on this curve. Then you're going to look at, and this is the new part, you're going to look at the min of these two distances. So you're looking for the closest point on the curve to you, whether it's this one or this one. And the goal of this is that this should encourage you to fill out most of this curve while also improving over points as much as possible. If you put a point down here, for instance, then you don't get anything for this because your final score is going to be if this is A and this is B, and you're going to get A times B. This is your score. So if you put the point down here, A is 0, you don't get anything. If you put the point like right on top, you don't get anything because you're already on top of an existing point. So your goal is to fill out this curve and improve over these adjacent points. This is a pretty nice algorithm. It's based on ImbueAI's carbs, but their version of this doesn't use adjacent points at all. It tries to substitute a function model of the curve, and then they just try to look for like where they think that they can improve over their model of the curve. And there are a whole bunch of degenerate cases that are not handled. Yeah, there are just a bunch of problems overall. The only thing I'm not completely happy about is, you can improve a ton over an existing point and you still get 0. I don't really like that too much. So I'm going to think about that. Because it's incentivizing you to try new spaces on the curve. So it's not terrible that it works that way. It just really wants you to fill in the curve. Okay, so this is a different test. Beautiful. 1 bad point total. This is perfect. I'm curious to see what this is going to do on Phong. Let's commit. Well, let's configure a couple things. First, let's configure a couple things. Sweep.metric. Phong. E7 minus 2E7. Auto. Okay. Reneo. Cool. So this is set up nicely. Let's commit everything. So we have it. Let's default. It's not very much code for this thing. Really not a ton of code for this. The original repository for carbs, for reference, was around 2,000 lines. Ours is going to end up between 400 and 500 most likely, though I might try to compress it even more than that. Because I think it would be funny. There's still some things I want to improve with this. Currently, the algorithm starts with random sampling. Around, well, it's directed random sampling, but still. I think that we have some things that could be improved there. We can improve the initial sampling. Yeah, because it's quite a lot to require 10 experiments before carbs really does anything, which is what we have now. I think after that, well, we'll see how this goes on Pong. Pong is one of many tasks that we can try. The whole idea of this is we have all these environments on Puffer AI. Right, you can play any of these. We've got breakout, we've got like fancy stuff like this, right? We've got multi-agent, snake, lots of environments. So hopefully, when we test this out on all those, we're going to figure out the gaps and the things that could be improved. And I don't want to ship this until I have something where I really feel like, okay, hyperparameter sweeps for RL are stable, consistent, and easy. That's the goal. Stable, consistent, and easy. And I think if we can do that, just so much of RL research is going to just feel better. And so much of RL in practice is going to just feel better. Because you're not going to ever have to wonder, uh-oh, are my hyperparameters just off, right? You're going to just be able to run the sweep. You're going to get like really good information out of that sweep. It's going to be fast. And yeah, that's generally going to be the case. And I think we're pretty close to that. Obviously, there's a ton of testing, there's a ton of tweaking. I could be wrong on various parts of this algorithm, but I think that the way that I've handled the normalization everywhere just makes good sense and should generally be pretty stable. There's still a couple things here and there that I'm not too sure if I like the exponential scaling with this like epsilon maximum. You need to have scaling. It should probably be exponential. I don't know how you should be clipping it or handling edge cases. So there's still stuff to figure out there. There's a resampling option as well where you can resample existing points. I think I probably need that because for environments where there's just a lot of instability, you kind of need to resample. Yeah, so there are a lot of different things that can be done there. I'm not going to get off just yet. I'm going to still do a couple additional things here. But since we do have a fair few folks watching at the moment, happy Valentine's Day. And if you're interested in getting involved in all this open source RL, you can join the Discord. It's just discord.gg/puffer. You can try all these environments out on puffer.ai. They're all very simple to read. They're all open source. Most of these are contributed by new RL folks in the Discord who have just, gotten involved with the stuff. So you don't really need a ton of RL experience for this side of it. And they're all very fast, like 10,000 times real-time fast. All the code is right here on the GitHub. You can star the repo to help us out. That really helps us out. And if you're looking to get into RL, I would suggest specifically this quick start guide. And if you're already an expert in RL, then we have some other articles on some of the work that we've done here, such as the 2.0 article, and I have some extra ones on my X as well. And while I've been saying all of that, we've mostly finished the random trials. I think it's 10 random trials by default. Is it 10 random trials, or did I reduce it to something? Interesting that it goes up this way. Let me see if I can find the previous best one that we're trying to beat. This one's pretty good. I think this one, but I don't think this is the best one. Let me see, this is the 34 one. This one better? That's the other one. I think this is the best sweep that we had. So we had like a Pareto front that looks like this. I thought we had a better one as well. No, I think this might be it, yeah. And then we had, what else? And there's so many different things we've tried here. Like, I think this one. This was a carb sweep on Pong. We didn't get the Pareto front out of this. Let's score. Okay, yeah, this is pretty representative. So we get stuff like this out of carbs before, which is pretty decent, right? You get like, what's this, 28 seconds, I think, run time to solve. So like it discovers good solutions, but like all this stuff in here is wasted. It runs a lot of pretty wasteful experiments. You can see I've been running like lots and lots of trials on carbs. This is all neo-carbs experiments. Name work in progress. But I think the first old version I had over here. That's it. Yeah, this was like a pretty stable version that I was running experiments on, not this one. It generally looks less wasteful in that most of the good experiments, right, like they're up here. It's not running too many failures down here. It's a little weird because like there are still points here that are not great, that you shouldn't be here. And then it clusters a lot of stuff down here, which is not good. So there are all sorts of different versions of this that I've run. I think that there's one on Breakout as well, so this is Breakout. Breakout is very noisy, so you're going to get bad runs regardless of what you do. I think we can do way better than this at least, though. Yeah, there are various different environments. So we do have some like nice benchmarks from the old version to try. But then the hope is that we're going to be able to get something much better. And this is the problem that I was having with something similar to the current version of the code, where it would kind of cluster a bunch of experiments up close to where it thinks it can solve, and then it would cluster a bunch of experiments at minimum cost. I think this was just bad data normalization. So we're going to see if this can do better than that. It's so cool to be able to run these things like in 1 to 3 minutes a piece. Okay, so interestingly, it is pushing up to max cost, it looks like. See the Pareto front? I might have it pushing too aggressively to max cost. It doesn't have a great model of performance yet. I mean, the good thing is it has to at least predict that it's going to improve over the nearest point. So the prediction model can be off, but it's not going to intentionally run experiments that are worse than existing points. Is this just unstable? This is weird that it's this low. Yeah, okay, there's some instability. I mean, the ideal thing, right, is that you get a pretty dense set of points around here in the cheap range, and then you fill in longer, and you get a nice clean curve. Yeah, it is definitely pushing the max cost. Maybe we can think about that just a little bit while this runs. Because I do technically encourage that, and I encourage it quite explicitly. So I set the mean function to 1. That shouldn't affect that, though. Your score function is... You do explicitly get rewarded for pushing the max cost. Shouldn't this happen anyways, even if you just deleted that term entirely? It should, in theory, right? Just how much can you improve over the nearest Pareto point? I think I remember the reason. So the reason that I added this term in there originally it wasn't anything to do with trying to push you towards higher cost. The reason I added this term originally is like if you have a point here and a point here, and you just look for where is the highest point that I can improve over the nearest Pareto to the left. Because you go to the left, you look for the nearest Pareto, and then you see where should I put your point to improve the most over that. So we'll just put a point like here, right? Because this is the biggest improvement, and then it would go like this and this and this. So it would just densely fill in and like scale back that way. So maybe this is being abused. Maybe this is being abused. You have options here. You could clip it, so you could clip points that are too far. There's a parameter you have to control how far away you can put points. The thing is, I really like the nearest penalty thing because it has a really nice interpretation. So if you do like the minimize distance to nearest point, then this is the best solution, right? And then maybe this is, and this is, and you literally end up doing binary search. So it has this very, very nice interpretation. So I kind of want to keep that term in, though that doesn't mean that I have to keep the boundary condition. Yeah, I could just use the mean distance or something like that. Okay, so we'll see how aggressive this thing is. If this thing is pushing towards high cost way too much, then we have options to handle that. So I think that the base algorithm is good. I really do. It's just a matter of boundary conditions and the like. Yeah, because it's not pushing everything to max cost yet. If we look at Pareto, we already have a point that's over 20. This is way too much running time for Pong. It should be able to do this back here. So I do think that this is pushing too high too quickly. Because it's getting rewarded for it. Yeah, see, look, it's getting this distance here because I don't even know how it samples that far. I don't think it should be able to sample this far away from this point. Yeah, okay, so there's definitely something screwy here. You're not supposed to be able to do this. So it could just be that. Because the thing is, if you're not Pareto, then you don't go into the sample index, right? So like it's not sampling around these points. It had to have sampled from like this point. And it's not supposed to be able to do this big of a jump. I don't even know how this point got run. This is ridiculous. Oh, to be fair, it is technically, it's possible to like, it could have been like this point ran and then this point ran or something, or this point. That still doesn't really make sense. No, there's no way they should have run. There's no point that they should have been able to have been sampled from. It is possible the cost model was just totally wrong. Even then, that shouldn't happen. Rad norm. Num n's. Okay, so it's pushed this down a ton, so this is going to slow stuff. And then update epochs is at 1 or 2 only. There's still quite a bit to do here. Okay. Well, this is good progress at the very least. The sweeps are running. They don't look totally degenerate. I will be curious to see if we don't get too much noise down here. If it pushes up to max cost, but most of the runs are of at least high quality, then that I think will be a success. And then we'll just have to adjust the sampling scheme a little bit more tomorrow. But I am going to be working on this for most of the weekend, so I will be streaming this all day tomorrow. And we're going to be doing more of this experiment side work. I'll see if I find other stuff to do in the middle, because, you know, you have to wait for the experiments to run. But probably the way I'm going to approach it is I'm going to start, you know, formally trying to write up some of this stuff, because there will be a nice blog post on this. And then I'll probably like fill in stuff along the way. So anything I want to make like a cool figure or cool visualization, I'll probably like make that and I'll run that as well. So we'll start like really trying to polish this stuff up. Though I don't think the results are not there yet, but it looks to me like mostly we are, yeah, it looks like mostly we are limited from the sampling and like the pushing up too far in cost. So now I'm looking at this, actually maybe this isn't bad, because it doesn't look like it's pushed all the way up just yet. Maybe this ends up being good. All right, I'm gonna call it here. For folks watching, once again, puffer.ai, start the GitHub, really helps. You can actually get all this code that I just did. You can go play with it. It's in the whatever fix neocarbs branch or whatnot. It's the latest commit. Join the Discord. Almost 1,000 people in here. Discord.gg/puffer. And yeah, lots of fun RL articles on here. If you are on X, lots of articles. This is all I do. We are going to fix reinforcement learning this year, and hyperparam sweeps is a big part of that. We're spinning up a few other efforts that I'll talk about soon, but for now, this is what we've got. All right. Thanks. Enjoy.